Welcome back. In the previous lessons, we made our SHL1 robot move in Gazebo using the full ROS2 control stack. We started with a URDF, then we had controllers, then we had a custom swerve drive plugin, and now today we will take that same robot and make it move inside NVIDIA Isaac Sim. The great part is that because everything we build follows ROS2 control standards, switching simulators is actually quite simple. So, in this lesson, we set up the workspace that bridges our ROS2 controllers with Isaac Sim. And you'll see how little needs to change, right? Because we follow ROS2 control standard. We'll create a new package for Isaac and update the RDF and add the topic-based ROS2 control bridge to communicate joint commands and states. So the learning objectives, we're going to create a dedicated package for Isaac Sim integration. We're going to compare Gazebo and Isaac Sim URDF and launch files. We're going to configure and use the topic-based ROS2 control bridge, and we confirm that controllers, configs, and everything else remains unchanged. So let's go. So here's our workspace, and the first thing I need you to notice is that we have a new package for Isaac. Okay, and this package is going to be quite simple. If we inspect inside, we will only have a launch file specifically for the Isaac setup. So if we look at the description where all the URDFs are, we also added a new one. So previously we had the Gazebo URDF Zacro, and now we have Isaac URDF Zacro because we need to make a few changes there. So let's have a look at the differences. But before that, notice that we have a topic-based ROS2 control package. Okay, we cloned this package from a Picnic Robotics repo. So it's a hardware interface that uses topics to command the robot and publish its state. So let's compare the older Gazebo file with our new addition, the Isaac Zacro or URDF Zacro. And if you notice, the entire robot definition is the same. Nothing changes except for at the very bottom, the configurations for control. So in one case, we had the ROS2 control configuration for Gazebo, and we had a hardware interface Gazebo's sim system, which was of a plugin G0 ROS2 control Gazebo sim system. So that is the bridge that Gazebo has to bridge ROS2 and the simulator, right? So to connect our joints to the simulator. And in it, we defined all of these joints, and we didn't really care if they were of type position or if they were of type velocity. Okay, so we mixed them. Position, velocity didn't matter. The plugin was able to distinguish between them. This is for Gazebo, right? So it uses this plugin. Now in Isaac we don't have that plugin, but we're gonna use the package, the topic-based ROS2 control package that we talked about earlier. And here, let me close this because it's easier to see if we only focus on the Isaac file. So here we're gonna create also a hardware interface, Isaac Sim Steer System. It's gonna use that plugin, the topic-based ROS2 control. Again, is this package that we cloned from, thanks to our friends from Picnic Robotics. And here we tell it that we're going to use a joint states topic to read the joint states, and the steer command topic to publish steering commands to the simulator. And we create this particular interface just for steering. And as you notice, all of the joints here are position joints, so are the joints that will move the wheels a little bit to the left or to the right by a certain angle to steer a robot. And the reason we do that is because this is a topic-based system, so we can't mix them like we did in Isaac. So here we have a second hardware interface. This time it's the same topic-based ROS2 control. It's the same plugin. But this time the joint states topics they are the same, sorry, but the joint commands topic will use a different topic, a drive command. So we have a steer command topic. Joint states will be the same, but to control the joints we use two different topics. And notice here we have only the velocity joints, okay, only the velocity joints. So we have two hardware interfaces, one for the position joints and another one for the velocity joints, and they will use they have different names, obviously, and they will use two different topics for controlling the joints, but they will share the same topic for publishing the state. So now let's have a look at the launcher. So the launcher is a little bit different from the way the Gazebo one was made. So we have here, we will have two lines of code to get access to two packages where the control configurations are. And although we added there the basic controllers one, the one we really care about is the swerve controller. But here's the one for the basic controllers that didn't use the custom swerve controller. But here we have the configuration for the custom swerve controller. And all I want to show here is that we're going to use the same configurations. We don't have to change them. Then we keep going down, and you can see things like we're gonna read here. What am I doing? Yeah, so we're gonna load some nodes. So we're gonna load the robot state publisher, just like we did with the Gazebo, and we need to give it the URDF Zacro. We're gonna load the controller manager node. Okay. In this case, we need to do it manually because we don't have this Gazebo plugin that loaded this manager for us before. So now we need to manually load it. But other than that, we're going to launch the joint state broadcaster. Right, the joint state broadcaster. And we also load the swerve controller, the custom swerve controller. And then here we just delay the loading of the load swerve controller until after the joint state broadcaster or publisher is ready. And then here we just list all of those nodes that we want to launch, right? So we put them in a list, and we optionally launch Gazebo. And then here we will define some of those parameters. So here we define the Zacro file we're gonna load, in this case the Isaac one. And then just other parameters like use the simulation time and use RViz. Okay, and then here we just create the launch description. We pass all the arguments to the opaque function. And this is different from what we did with Gazebo. We need this opaque function so that we can pass it some arguments like the location of the Zacro, but in particular the location of the configurations. And again, what I want you to keep in mind is that we didn't have to change any configuration. So if we look a little bit at the Gazebo launcher, it looks a little bit different, but what I want you to notice is the biggest differences are that here we need to spawn the robot manually in Gazebo. Well, not manually, through the launcher. And here we also have this node to launch the Gazebo bridge. And here we actually launch the simulator. Right, so after the simulator, this is how we spawn the robot in the simulator. But we don't have any of that in the Isaac launcher because we will launch Isaac as sim manually. We don't launch it through the launcher. But the most important part is that this controller configurations did not change. Okay, all we had to do, they stay the same. All we had to do was to create a new launcher for Isaac and change the plugins that we're going to use in the in the URDF Zacro file, and that's it. That's all we needed to change. Everything else stays the same. That's the beauty of using ROS2 control in its most standard way. So let's just test it. So source the workspace and let's launch. I previously built it, so but don't forget to build it if this is the first time you're using it. And then we're gonna use the Isaac package, and we're gonna use the Isaac launcher. And most things will look familiar, but in particular, I want you to notice here that we have loaded those hardware interfaces, and we should see two, right? One for the steering. We're gonna see that later. But look at, there's an error here. Obviously, there's an error. If you see in the RViz, there are no wheels, and here the robot model section is complaining that we don't have all of these wheel joints, and of course we don't, because our simulator is not running. Isaac is not running, so we don't know what's going on with those joints. Okay, but let's inspect some of the nodes to see if everything is under control relatively. So we have a controller manager, we have the joint state broadcaster, robot state publisher, so everything is good. And we also have the Isaac sim drive system and steer system. Remember, we have two plugins, one for the drive joints and one for the steer joints. So it's looking good in terms of nodes. And then in terms of topics, we have that drive command. Remember, this is to send commands to the through the drive system to the joints that will steer. And then we have for the joints that will move, and this have the steer steer topic for the steer system. This is for the wheels that will turn. Steer. Okay, this is confusing, I know. And then we have joint state broadcaster and robot state publisher. They will read the state of the joints from the joint states. Okay, all these topics are published by this hardware interface that we are using in place of the Gazebo plugin. So yeah, it's failing because the simulator is not running. So we're gonna fix that soon. And in the next lesson, we're gonna connect the second part of the system, which is running Isaac Sim and creating a graph within Isaac Sim to subscribe to the necessary joint command topics and publish the joint state. So see you in the next lesson.